All right. Welcome, environmental science class. We'll be talking about human population organization. So this will be chapter 14. Okay. So today we are going to go over 14.1. Again, this is going to be dealing with human population growth and essentially where we're at with that, what the growth rate is, how we're going to see it in certain areas, not certain areas, what we see in the past and how we grew, where our growth rate is now. So just a few things for 14.1. Okay, so uh, the case study that we're looking at is that essentially the population for humans is around 7.3 billion. Again, this may not be accurate as of right now, but again, it's around 7.3 billion. Okay, and think about this. Our growth rate has really exploded in terms of any type of species. Okay, so two, around 200,000 years, our population grew 2 billion by 2 billion. So again, our numbers are astronomical when it comes to how much a mammal has grown, right? But it took less than 50 years to reach the second 2 billion. So again, to get our first 2 billion, it took 200,000 years. Our next 2 billion took 50 years, and then it took 25 years to reached the third billion. Now, 13 years later, we're at 7.3 billion. So this is telling us that yes, our growth rate is increasing at an exponential rate. It's going higher and higher, higher exponentially, and it seems like nothing will stop us. And what we see is that most of the world's population is going to be, or has, or will live in cities. And again, we'll talk more about that in essentially human population. All right. So, the hypothesis about how population sizes are going to grow is dependent on this demographic transition hypothesis. Is that as different countries industrialize and develop economically, per capita, there's going to be income rising, so there's going to be a lot more money. Poverty declines, so there's going to be less people in poverty. And populations will grow more slowly. And again, we're going to look at different examples as to why and how that is the case. Okay, so if we look at the different stages at which different countries can be at, what we see is that stage one is where, again, all countries begin with. And you're going to see that you're going to have a lower population, but the birth rate is going to be high, but you're also going to see a lot of death rate. And again, that deals with a lot of different factors of medicine, technology, how much food's available for you. And then once you get to stage two, that's when you start to see your population growth increase because that's where the death rate decreases. Stage three is when you start to see birth rate decrease. Death rate is about the same, kind of plateaus. And then by stage four, your population growth is very steady. But your birth rate does go down. And again, we'll talk about the different factors that contribute into that. So, stage one, as we look at our chart here, stage one is where all countries are going to begin. Stage two, we see that countries modernize. They have better nutrition, sanitation, medicine, and all these are going to lower the death rate. Again, healthier people are going to live longer, causing for populations to increase. Stage three, as modernization continues, families are going to have fewer children, which is then going to lower the birth rate. Again, if you expect your children to survive for a long time, you may not want to have a lot of children. And again, this deals with the idea of not living on farms, maybe living in cities where you might not need a family of 10 to support or help, keep up the farm. But in cities, you're going to see more smaller families. And then stage four, what we see is that the transition is complete when you see that population growth does stop. Again, you're going to see more of a constant population. You're not going to see an increase in population. All right, so 14.1, how many people can Earth support? So the impact of rising human populations on natural capital raises the question, how long can the human population keep growing? And this is a really good question because, as we've learned before, with limiting factors, with population growth and all that, is that exponential growth, that J curve, you're going to see that everything's great, everything's awesome. Nothing's going to stop you. There's no limiting factor that restricts you from growing at an exponential rate. So what you see is that your population keeps climbing and climbing and climbing, but then that's when you reach your carrying capacity. When there is that limiting factor that causes your population to kind of plateau, it's not going to keep growing. And so there's a lot of things that can go into play. Maybe there's a lack of food. Maybe there's a lack of space. Maybe there's a deadly disease that causes people over 50 to die, right? A lot of different examples, but it's the idea that there will be a limiting factor someday, I don't know which day, but someday that the human population will not continue to rise at a constant rate. Again, what you're going to see is that eventually you're going to hit that logistic growth because of different limiting factors. And so the human population in history has grown slowly. But in the last 200 years, that's where we have started to see the rapid growth taking place. And there are a few factors that go into it. One, we used to be hunters and gatherers, that meaning that we would go out and we would hunt for our food, whether it was different animals, different plants. And so that really restricted how much you can eat. Again, it was how much you could find. That's how big your population is going to be. With the introduction of modern agriculture, this allowed for a constant supply of food. There wasn't a chance, you were always going to have a supply. So you could increase your population the more food that you're able to successfully grow. Okay, and technology has helped humans migrate to live in a lot of different places and zones. So again, with technology, with medicine, with all these things, we have allowed to live in places that in some places might not be habitable. But because we have the technology to keep us alive, to keep us healthy, keep us warm in these different climates, we are able to continue to grow. We're able to live longer because of that. And again, as long as we're able to reproduce, we're able to eat, get some energy somehow, find a place to live, not die of environmental causes, then you're going to see that we have survived. Again, if you think about our age, the certain amount of age or the average amount of your life expectancy, you're going to see that over the years, our life expectancy has increased. Again, if you think about during the medieval times, people wouldn't really live past 40. And that was just based on the technology that was available. But if you look at what we have right now, you're seeing that people are living to, their 70s, their 80s, 90s. Even some people live to 100. And that's because of all of the technology that we have and all the food available. And so what we're seeing is that there's going to be three current trends in the population, in the size and impact of human population. So since the 1960s, the growth rate of the human population has slowed, but this population is still growing. Again, it's slowed. It's a slower rate, but it's still growing. The human population is unevenly distributed. And again, we'll talk about that more when it comes to essentially the country state, when it comes to how advanced they are, how modern they are. So again, if you look at less developed countries, you're going to see that their population is growing 14 times faster. But in more developed countries, again, you're going to see that it's less. And then people are moving to urban areas. By 2050, 2/3 will likely move into the cities. Okay. And so with that, moving into the city, you're not going to need or want a big family. But if you live out in the farms, you live out in rural areas, you might want a bigger family to help support the farm, make sure everything's good, or you just have more space. You might have more opportunities to have a bigger family. If we look at the growth human population rate, again, this is just an example of how the growth rate would go. So again, this is how much the population would increase. It's not saying that it's not going to stop increase. It's just a chart and a prediction. But we are looking at this chart from about 2012. It looks like here. And so obviously 60s, 70s, we had a huge spike. So each year our population would increase around 1.5 to 2.2% each year. And then by the 2010s, we're starting to see that it's around 1.2, maybe 1.1. And with this trend, it's going to continue to go down. But that's just a trend. Again, a lot of things can change with the increase in our population growth rate. But again, the current model shows that we will. Okay, this might be easier for you to see. That it will go down by 2050, and we should expect to see a growth rate. So again, we're still growing by around 0.6, 0.8% each year compared to what we've had before. This is all for 14.1.